Welcome students, in this class we will be studying about Laplace transform of convolution. Before we could start off with applying Laplace transform to convolution of functions, we must know what exactly convolution of two functions means. Suppose you are given f star g of t. This is how we represent convolution of two functions. Now this is equal to integral 0 to t f of t negative u times g of u times du. Now this can also be rewritten as integral 0 to t f of u g of t negative u times du. So these two can be used depending upon the question that is asked. So they come in handy. So this is how we define convolution of two functions. Now, if we were to be given, say, so in which we are expected to apply Laplace transform for the convolution of two functions, then the outcome is equal to f of s product multiplied with g of s, where Laplace transform of f of t is capital F of s and Laplace transform of g of t is capital G of s. So this is exactly the outcome we will get when we apply the Laplace transform for convolution of two functions. Now we are going to do some problems using these definitions. Students, we are given this question. We are expected to find the Laplace transform of integral 0 to t 3 of t negative u raised to the power 2 times sine 2u times du. Now this is similar to finding the Laplace transform of integral 0 to t of f of t negative u times g of u times du, where f of t negative u is equal to 3 times of t negative u raised to the power of 2 and g of u is equal to sine 2u. So now clearly f of t can be obtained from here. So if I were to take, let t negative u be equal to t, then f of t is going to be 3 times t squared, and if I were to take in this case u to be equal to t, then g of t is going to be sine 2t. Now let us find the Laplace transform of f of t, which is nothing but Laplace transform of 3 times t squared, which is nothing but 3 times of Laplace transform of t squared. Now we know that the Laplace transform of t power n is n factorial divided by of n positive 1. So this is equal to 3 times 2 factorial divided by s raised to the power of 2 positive 1, which is 6 divided by s cubed. So Laplace transform of g of t in this case is going to be Laplace transform of sine 2t, which is equal to 2 over s squared positive 2 squared, which is 2 over s squared positive 4. So therefore the Laplace transform of the convolution 0 to t f of t negative u times g of u du is given as f of s product multiplied with g of s, which is nothing but Laplace transform of f of t times Laplace transform of g of t, which is equal to Laplace transform of f of t is 6 divided by s cubed, and Laplace transform of g of t is 2 over s squared positive 4, which is 12 over s cubed times s squared positive 4. So this is the Laplace transform of integral 0 to t 3 times of t negative u raised to the power 2 sine 2u times du. So this will be the solution. Students, we are expected to find the Laplace transform of integral 0 to t u times e raised to the power of negative 2 of t negative u times du. Now this is similar to, let me write that down, this is similar to finding the Laplace transform of integral 0 to t f of u times g of t negative u times du, which is nothing but f of s times g of s. So we will be using the convolution. So by comparing, clearly we see that f of u is equal to u and g of t negative u is e raised to the power of negative of t negative u. Now if I were to take t negative u is equal to t, then this would mean g of t is e raised to the power of negative 2 times t. Over here, if I were to take u is equal to t, then this would mean f of t is equal to t. So let me find the Laplace transform of f of t. This is going to be 1 over s squared, and the Laplace transform of g of t is 1 over s positive 2. So therefore the Laplace transform of the convolution, which is given as integral 0 to t u times e raised to the power of negative 2 of t negative u times du, is equal to 1 over s squared times 1 over s positive 2, which is rewritten as 1 over s squared times s positive 2. So this is the solution to this question. Students, we are given this question: verify the convolution theorem given that f of t is t and g of t is sine t. So the convolution theorem states that, let me state that Laplace transform of f star g of t is equal to capital F of s product multiplied with g of s, where the convolution f star g of t is written as integral 0 to t f of t negative u times g of u times du. So this is the definition when you have the convolution of two functions, and the variable under consideration is u. So this is very important. Now what we are going to do is we are going to prove this. This is the subject of contention, okay, with the function f of t being t and the g of t being equal to sine t. So foremost, let us consider the left hand side. So we got Laplace transform of f star g of t, which can be rewritten as Laplace transform of, now f star g of t is this integral 0 to t f of t negative u times g of u times du. Now given f of t is equal to t, this means f of t negative u is equal to t negative u, and g of t is equal to sine t. It's given, right? So this would mean g of u is equal to sine u. So if I were to take this as 1, using these in 1, we get, so what do we get? This would be Laplace transform of integral 0 to t f of t negative u, substitute t negative u, and g of u is going to be sine u times du. I can rewrite this as integral t times sine u. So t times sine u du, limit 0 to t, negative integral u times sine u. So u times sine u du, the limits are 0 to t. Now t is a constant, so take that out. So Laplace transform of t times integral 0 to t sine u du negative. Now we need to apply uv method. So let me write that down again. Integral 0 to t u times of sine u du. Now this is going to be, integral of sine u is going to be negative cos u. The limits are 0 to t. Of course you have a t there. So this is actually a Laplace transform of this quantity. Followed by, now let me use the rough column to perform the integration. So this is integral u times sine u du. Now what we will do is we will take the Liet rule. So integration by parts. Integration by parts. According to integration by parts, u dv is equal to uv negative integral v du. So we will take the value of u. Apparently we have variables u and du to handle. So I will just take this u to be equal to capital U. So du is going to be equal to du here. So my dv is going to be this quantity sine u du. So if you were to integrate, you get v is equal to negative times cos u. So integral u dv, that's going to be my u times dv is sine u du, and that is equal to uv. My u is capital U and my v is cos u, so it's going to be negative cos u. Of course I'm not going to touch the limits now. Let's hold the limits just for now, and then I will replace it. So minus integral negative positive cos u. Of course my du is just going to be this du. I hope you are able to follow what we are doing here. Because of this formula, I hope things don't get confused. So the limits are 0 to t, and the limits would be 0 to t and 0 to t. So if I were to substitute the upper limit, so it's going to be negative t times cos of t. I substitute the lower limit, this is going to be 0, right? Followed by integral of cos u will be sine u. Limits are 0 to t, so this is going to be negative t times cos of t, followed by sine t. So this is going to be 0. So this is what I have got. So we have to take this and substitute it here. So that's going to be negative t times cos t positive sine t. And in this case we will have to apply the limit. So this is Laplace transform of, so t times, I substitute the upper limit is going to be negative cos t, substitute the lower limit, it's going to be negative of, there is already a negative sign here, this is going to become positive, negative of negative cos 0, that's going to be 1 there. So this sign can be taken out, so it's going to be positive. In fact I can bring the sign in and remove the parenthesis, so it's going to be positive t times cos t negative sin t. So this is what we have got. Now if I were to take the t inside, it's going to be negative t times cos t positive t times cos t negative sin t. Negative t times cos t positive t times cos t gets cancelled, giving me Laplace transform of t negative sin t. So this is what I have got. So now we will have to calculate the Laplace transform of this. So this is nothing but Laplace transform of t negative Laplace transform of sin t. Laplace transform of t is 1 over s squared, negative Laplace transform of sin t is 1 over s squared positive 1. If I were to take the LCM, s squared times s squared positive 1, this is going to give me s squared positive 1 negative s squared. S squared negative s squared gets cancelled, and that is going to be equal to 1 over s squared times s squared positive 1. So what is this exactly? This is nothing but the Laplace transform of the convoluted function f star g of t. But we know that the Laplace transform of the convoluted function f star g of t is equal to f of s times g of s. So we have only found out the left hand side, right? So we need to find out the right hand side. Okay, so consider Laplace transform of f of t. What is that? Laplace transform of f of t. Now if you were to go here, the Laplace transform of f of t, f of t is t, right? So which is nothing but, this is going to be Laplace transform of t, which is nothing but 1 over s squared, and we will consider Laplace transform of g of t. What is g of t? Sin t. So this is nothing but Laplace transform of sin t. What is that? That's going to be 1 over s squared positive 1. So hence Laplace transform of f of t times Laplace transform of g of t is equal to 1 over s squared times 1 over s squared positive 1, which is equal to 1 over s squared times s squared positive 1, right? So what is this exactly? You see this? This is what we add for the left hand side, and this is what we are getting for the right hand side. So if I were to take this as say 3, and if I were to take this as 2, from 2 and 3 we observe that we observe that the Laplace transform of f star g of t is equal to Laplace transform of f of t times Laplace transform of g of t. But what is this Laplace transform of f of t? F of s. What is this? This is nothing but g of s. So what do we conclude from here? This means hence the convolution theorem is verified, right? This is the exact essence of the convolution theorem. So we will move on to the next question. Students, we are given this question. The question wants us to find if Laplace transform of sin t times cos t is it equal to the Laplace transform of convolution of sin t with cos t. So let's do this. So first what I wish to do is I would like to take the right hand side. Consider the right hand side. So what have we got? We got the Laplace transform of convolution of sin t star cos t. Now we know that Laplace transform of convolution of f with g of t is equal to the Laplace transform of f of t times the Laplace transform of g of t. It is also rewritten, in fact you can also write this as capital F of s times g of s. So we know this. Now what we would do is hence Laplace transform of sin t convoluted with cos t is nothing but Laplace transform of sin t product Laplace transform of cos t. But what is Laplace transform of sin t? It's going to be 1 over s squared positive 1 squared, so we can write it as 1 times Laplace transform of cos t is s over s squared positive 1. So I can rewrite this as s over s squared positive 1 times s squared positive 1. So that's going to be s squared positive 1 raised to the power of 2. So what is this? This is nothing but Laplace transform of sine t convoluted with cos t. So this is what we have got. Now I'm going to say consider the left hand side. The left hand side is Laplace transform of sine t times cos t. So this is the product between sine and cos. A product is taking place. Okay. Now we know that. What do we know? We know that sine 2t is 2 times sine t cos t. So from here, this would mean my sine t times cos t is equal to 1 over 2 times sine 2t. So I can rewrite this as Laplace transform of 1 over 2 times sine 2t. This is a constant, take it out, 1 over 2 times Laplace transform of sine 2t. And this is nothing but 2 over s squared positive 2 squared, right? My 2 and 2 can be cancelled, giving me 1 over s squared positive 4. So if I were to take this as 2 and if I were to take this as 1, from 1 and 2 we conclude that the Laplace transform of sine t times cos t is not equal to the Laplace transform of sine t convoluted with cos t. So this is a nice handy result.